This conference will now be recorded.
Good evening, guys. So my name is Sanjay and I welcome all of you to this online session on AWS Solution Architect Associate. So our today's agenda is VPC, Virtual Private Cloud. Okay. So before starting this, I want to clear you a few networking things, so then you would be able to understand the VPC concept. Okay. So VPC means you are going to create your own private infrastructure where you will place your RDS instances, your EC2 instances, okay, and your other services like your SQL instance. So this you can place into your in your private infrastructure, similar like your on-premise infrastructure. So first of all, let's discuss about your on-premise infrastructure. In your on-prem infrastructure, when you are going to set up a data center, so you need to set up first of all your network. Okay, you need to design your network. So for your network, you will use routers, switches, okay, cables, patch panels. So these equipments you will use for network, and then after physical arrangement, you assign to design your network address, like your IP address, okay, IP address range, which you will use inside your network or inside your organization. So like your, let's take an example, 192.168.0.0/24. Okay, 172.16.0.0/16. So these are ranges you are going to use inside your network in your on-prem. So similar like that, AWS is giving you, okay, your whole network infrastructure as a service, okay, where you don't need to worry about this underlying hardware, okay, this infrastructure, okay. What you can do, you can focus directly on your network side, your network address, your subnets, okay, and then you can place your devices or your resources inside that subnets, inside that network, okay. So without worrying about router switches, patching, cables, okay, you can create your own infrastructure, which would be a private infrastructure for you. So that's why it is virtual private cloud. Okay. So hope this would be clear to you. So first of all, let's discuss about IP address. Okay. So when we are discussing about IP address, so right now we are going to discuss about IPv4. So there are two kinds of IP addresses, there are two versions, IPv4, IPv6. So the length of IPv4 is 32-bit and IPv6 is 128. So we are going to discuss about IPv4 right now. We're not discussing about IPv6. So the structure of IPv4 is you will get four octets which are separated by a decimal. You can say a dot. Okay, and each octet contains 8 bits. In total is 32 bits. So that is the structure of IPv4. Now there are two terms in IPv4: network and host. Okay, and IPv4 address is also divided into classes: class A, class B, class C, class D, class E. So class A range is 0 to 127. Okay, and usable range is 1 to 126. 0 and 127 both are reserved. Class B is 128 to 191. Class C is 192 to 223. Class D is 224 to 239. And class E is 242 to 255. So that means in IPv4 you will get the things from 0 to 255. This is the number which you will get. So everything would be inside this number between 0 to 255. So that number is called block size. That is your block size, so which is 256 in IPv4 case. So block size is 256. Hope this will be clear to all of you. Now let's discuss about class. So if we're talking about class A, so all class have some different structure. Okay. So we are going to discuss about all these first three classes A, B, and C. Okay. D and E we cannot use, a normal person cannot use. So D is for multicasting and E is for R&D, research and development. So a normal person can use only class A, B, and C. First of all, let's discuss about class A. So the structure of class A is network, host, host, host. That means first octet is used for network and rest three are for host. Host means IP address, the computers. So the computers which will get IP address, they are known as hosts. They are known as nodes. Okay. So they will get address from here. Network will represent group of hosts. Class B structure is network, network, host, and host. For class C, structure is network, 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 and host. So you will get maximum. That means you can say number of hosts, maximum number of hosts in class A, maximum number of hosts. In if we're going to assign any, if you're going to configure network address for any medium to large organization, then we can use class B address. Okay, and for class A, we can use for corporate or enterprise network. And if we are going to configure network address for a small organization, okay, or for LAN, so we can use class C address as the number of host bits are less in class C. Okay, this is the basic about IPv4. Now let's discuss about subnetting. So when we are going to discuss about subnetting, so first of all we need to understand CIDR, which is known as class inter-domain routing. So I hope you all are aware about this address. Okay. So whenever you will see that address 192.168.0.0, this /24 portion is known as CIDR, which will define that how many bits, how many network bits you are using for this address. Okay. And this address will also define your subnet mask, you can say. So this address will tell you that how many bit subnet mask you are using for this address. So that is known as CIDR. So how you will calculate these CIDRs? So if you remember in our octets we have 8 bits. So let's expand these bits 1, 2, 3, 4, 5, 6, 7, 8, and they all have predefined values 1, 2, 4, 8, 16, 32, 64, 128. So when we are talking about bits, that means we are talking about binary system 1 and 0. So if your all bits are 1, so your octet size would be 255. This would be 255. And if they all are 0, that means octet size is 0. So your block size, that means your whole octet size is 256. I hope you remember. Okay. Now let's suppose if we have to write 1 bit subnet mask. So 1 bit subnet mask means the first bit is on and rest are 0. Okay. So that means 128.0.0.0. This would be your 1 bit subnet mask. First bit value is 128, rest are 0. That means you have total 32 bits. Okay. From 32 bit, you are going to use only 1 bit and rest 31s are 0. So this would be a subnet mask, 1 bit subnet mask. Then 2 bit subnet mask. 2 bit means your 2 bits are on. So 128 plus 64, 192.0.0.0. This would be your subnet mask for 2 bit. Then /3. So 3 bits are on. So this would be 128 plus 64 plus 32. So that is 192 plus 32. This would be 224.0.0.0. Then 5 bit, 4 bit subnet mask. So we need to add 16 as well. So 224 plus 16. This would be 240.0.0.0. Then 5 bit. So 5th bit is 8. So 248.0.0.0. And then 6 bit, that means 4 we need to add into 254, 258. So this would be 252.0.0.0. Then 7-bit subnet mask, we need to add two more, also. So this would be 254.0.0.0. Then 8-bit subnet mask, so we need to add one also. So 255.0.0.0. So that is the default subnet mask of class A. Okay, why? Just remember the structure of class. So that is the structure of class A. So that is network bits. So when you are calculating subnet mask, so from structure you need to on your all network bits. So that would be the subnet mask of your that particular class. Okay, so that is the subnet mask of class A. Similar like that, if you have to write down 9-bit subnet mask, so that means 255. So 8 bits are already filled here. The value of those bits are 255. That octet is 255. Then you need to move into your next octet, and next octet's first bit is on. So the value of that bit is 128. Then 0, then 0. That is 9 bits of that mask. Then 10 bit 255 dot 192.0.0. Then 11 bit 255.224.0.0. Then 12 bit subnet mask 255.240.0.0. Then 13 bit 255.248.0.0. Then 14 bit 255.252.0.0. Then 15 bit 255.254.0.0. Then 16 bit subnet mask would be 255.255.0.0. So that is the default subnet mask of class B. Similar like that, you will calculate your subnet mask, your CIDs. So these are known as CIDs. Okay, these are CIDs. So slash 21, slash 22, slash 23, they all are CIDs, and you have to have knowledge about these CIDs because they will tell you that how much bits you are using for network and how much bits you are using for hosts. Okay, so let's take an example. Hope this would be clear. Let's suppose I have an address 172.16.0.0 slash 24. Now I need to check that how many hosts I will get in this address. There is a formula 2 raised to power h minus 2. Okay, where h is number of free host bits. Okay, so as for my CIDR, I'm using 24 bits for my network. So I have total 32 bits. Okay, so that means 8 bits are for host. Okay, if I'm using 24 bits for network, so that means 8 bits are free for host. So you need to place here 8 and this would be 254. That means you will get 254 hosts for your this particular network as per your CIDR. So if you have knowledge of your CIDR, then you would be able to understand that how many networks and how many hosts as in your per network you will get. Okay, hope this would be clear to all of you. Now in IPv4 address, we have two kind of addresses. One is class full address and one is class less addresses. Class full address means you are using default subnet mask. That means for class A, you will use 255.0.0.0. For class B, 255.255.0.0. For class C, you will use 255.255.255.0. That is slash 8, slash 16, and slash 24. So if you are using these addresses along with your class, okay, that means you are using class full addresses. Apart from that, except from that, if you are using any CIDR which not belongs to your class or to that class which you are using here, let's suppose like 10.0.0.0 slash 9, okay, from slash 9 to slash 30 if you are using, that would be a class less address. Class B 16 to 30, that would be class less address. So that is just an example. So if you are not using default subnet mask, that means you are using class less address. That means that address is subnetted. Is it clear? Now I'm going to give you an example of subnetting as well. Then we'll start the VPC section. So subnetting. Now let's suppose I have an address 192.168.0.0/24. Okay, And this is my organization. Inside my organization, I have these departments: HR, sales, IT, and marketing. So I have four departments, and what I need to isolate these departments so they would not able to communicate with each other, and the users who are from HR departments, they would be able to communicate only with the HR department. So I can isolate my all departments through subnetting. Okay. So what I want to divide that address into smaller segments as per my requirement. So my requirement is I need four networks. So there is a formula for subnetting. So before starting that formula, first of all, you need to write down the subnet mask as per your CID, which is given to you. So that is 255, 255, 255 dot, and expand your all host bits here. 1, 2, 3, 4, 5, 6, 7, 8. These are the host bits which are free right now. Okay, that is your /24-bit subnet mask. Now, there is a formula 2 raised to power n greater than or equals to required network. So calculating is subnet mask. So 2 raised to power n greater than or equals to 4. That is my requirement. I need 4 networks. So I have to place here value which will be equals to 4 or greater than 4. So 2 raised to power 2 greater than or equals to 4. So n's value is 2. So how much value I get here? I got here. I need to borrow that much bit from my host portion. Okay, from my given address which is given to me. So and free and from free host bits. So right now I have 8 free host bits, and you need to borrow these bits from left to right. So my n's value is 2. So I need to borrow 2 bits from my host portion just because network portion is already filled. That is already in use. So if you are going to borrow anything, so you can borrow those things from the free portion. So my host bits are free right now, so I can use those bits into network. So now my subnet mask would be 255, 255, 255 dot 1112345 6. That is my subnet mask. So as per my scenario, this would be 192. That is my subnet mask, and that is called subnetted subnet mask. Okay, so now I will use that subnet mask inside my organization. So then my systems will assume that they are in a subnet, in a particular subnet. They will assume. Now, next thing is block size. So my default block size is 256, and I have to subtract that value which is changed in my subnet mask. So 192 is changed. So this would be 34. No, sorry, 64. 64. So 64 is your subnet mask for your subnets. That means this value will define your subnet's address. So as per your block size, the first subnet would be 192.168.0.0, and now you will use /26-bit subnet mask. So /26 is that subnet mask. Okay. And your next address would be next subnet would be, or you can say next network would be 0.64/26. So /63 would be broadcast address for your first subnet, and /62 would be your last valid IP for the first subnet, and .1 would be the first IP of your subnet. So that means you can use 62 PCs, 62 IP addresses. You will get 62 IP addresses inside a subnet. So you can cross verify that thing through the formula. If you remember 2h-2, which is used for calculating number of hosts in a network. So right now we have only 6 free bits inside our CID. So 2 raised to power 6 minus 2 which will be 64 minus 2, that is 62. So that is correct. So next subnet would be 192.168.0.164 plus 164, 128. Okay. So systems or IP addresses which belongs to 1 to 162, they will communicate, and they will not communicate with 64, and the range which is coming from 65 to 126, they will communicate with each other and they will not communicate with another. So this is the concept of subnetting. Hope this would be clear to all of you. And then you can use these subnets in your departments. Hope this would be clear to all of you. Now let's come to VPC section. So for VPC, what you will do, first of all, you will design your address. Let's suppose that is your VPC, virtual private cloud. So you will specify your address. So let's suppose I'm specifying here 10.0.0.0/16. That is my VPC's address. Now I have to create some subnets inside that VPC. So what we can do, we can create two kinds of subnets. You can say it would be front end or public subnet, back end or private subnet. Okay, so the resources which you want to connect with internet, those resources you will place into public or front-end subnet, and the resources which you don't want to expose on your internet and you don't want to give any internet connectivity, so those kind of resources you will place into backend or private subnet. So let's suppose if I have any web application, definitely this would be a front-end server. So I will place that server into public subnet, and this will be connected with my RDS or my database. Let's suppose that is my RDS, National Database Services. Okay, so I don't need internet connection on my RDS, and I want to place that IVS RDS into. Then I will place that RDS into private subnet. So there would be no internet connectivity on RDS instances. Now, when you are going to connect your public instance for internet connectivity, okay, what you need route table, internet gateway. So you need an internet gateway. So by that internet gateway, you would be able, the users, your resources would be able to connect with internet. Okay, and you can manage your flow with NACL, network ACL. So you can control your stuff or your subnet level of filtering through NACL. So it's a stateless, you can say it's a stateless firewall. So there are two kinds of firewall, stateful firewall and stateless. So that NACL is stateless, and the security group which we are using for our EC2 instances, that is stateful. So hope this would be clear to all of you. So for internet activity, we need internet gateway. Okay. So I have a picture. Let's understand that into a picture. So for your instances, you need security group. For your subnet, you need NACL. So both are firewalls. Okay. And this is your public subnet. That is your private subnet. Okay. That is the subnet addresses. This is your VPC address. That is your region where you have created your VPC. For internet connectivity, what you need internet gateway, or you need VPN, virtual private gateway, VPN gateway. Okay, and then you will add your address, your you will add that route into your route table, and then the resources would be able to connect with internet. So we'll do all these practicals one by one. I'm going to show you that thing practically. So let's move to our AWS portal. Let's search here VPC, or you can go to networking section. So let's search VPC, click on it. So by default in AWS, you will get default VPC. If you don't have knowledge of networking, so what you can do, you can use that default VPC for your resources. you don't know how to create VPC. So just move to your VPC tab. There is an option create VPC. Okay, and if you will click on your dashboard, and from there, if you will click on launch VPC visa, so you get option VPC with a single public address, public subnet. So it will automatically create internet gateway route table for you. Okay, and it will create a public subnet for you. So if you don't know anything about your network address and how to create your default gateway, how to create route table, and how to create internet gateway, then you can use these templates. Okay, VPC with public and private subnets, VPC with public and private subnet, and hardware VPN access. So these are the templates which you can use for creating VPC. So I'm going to create individually all the things, so you would be able to understand each and everything. You can see there is a default VPC. So let's give a name to that default VPC. Now we are going to create a VPC. So click on create VPC tag. So demo VPC. Then your IP address range. So 10.0.0.0/16. Then you want to use IPv6. No, I don't want to use IPv6. Tendency will be default. Click on create. This will create a VPC for you. So that is my VPC, default VPC. Now let's move to subnets. Now we will create some subnets for our default VPC. So click on create subnet. So this would be my public subnet, public demo. VPC would be my demo VPC. Okay. Then availability zone. In which availability zone you want to place your that subnet. So if you will not select, AWS will select automatically availability zone for you. Okay. But if you want, you can select manually. Let's suppose I'm going to create into East US 1A. So you can create public subnet into multiple availability zone if you need high availability for your web application. Okay, and then you can use ELB elastic load balancer or auto scaling for high availability. Now range. So range would be 10.0.0.0/24. This would be my address for my subnet. Click on create. Click on host. Create another subnet which will be private demo. VPC would be demo VPC and availability zone would be 1B. So I'm placing in different availability zone. And CIDR would be 10.0.1.0/24. Click on create. So right now I have two subnets, private, public. Okay. So select your public subnet and go to actions and modify auto IPs and IP settings. Auto assign IP address, yes. So it will assign automatically a public IP address to your resources. But it will not assign, right now it will not assign any public IP address to your resources. Why? It's because you need an internet gateway. So if you move to internet gateway tab, okay, right now there is one internet gateway which is attached to default VPC. Okay, so we have to create our internet gateway here, first of all. So I'm going to give name demo -izw. Click on create. So that is created here. Okay, it is detached. So first of all, we need to attach that internet gateway to our VPC. So attach to VPC. Select your VPC. So in my case, my VPC is demo VPC, and you can attach only one internet gateway with a VPC. So that is attached. Okay. So just give name to this also. Default. Now moves to route table. So you can see there is a route table for default VPC, there is a route table for our demo VPC. So I'm not going to use that route table. I'll create an individual route table for my public and private subnet. So name. public demo. VPC would be demo VPC. It would be. Then private demo. Close. Now let's select public demo. Go to subnet association. Which subnet you want to associate with that route table. So click on edit subnet association and select here public demo subnet. Click on save. Now let's move to routes and click on edit routes. So click on add routes and we want to allow all internet communication. Okay, so we'll specify here this address for IPv4 and target would be our internet gateway. So let's select internet gateway here. So you will get your gateway here which is attached to your VPC. Select that gateway. Now the resources which we will place into public subnet, they all will be connected to internet. Now let's select private subnet and move to subnet association. Select private here. So the basic structure we have done. So we have internet access on public subnet, and we don't have internet access on private subnet. So let's move and create some instances and let's check. So open EC2 console. Move to instance tab. Click on launch instance. So I'm going to select that EMI storage. So select here your VPC, which is demo VPC, and select here public demo. So you can see auto assign IP address is enabled. Okay, because I enabled there. Now scroll down and what we need. Rest things will be same. Okay. So click on next, add security group. So I'm going to use default security group, existing security group. So right now there is no security group. Let's create new one. Demo SC. Demo public SC. So SSH will be enabled. Okay, that is fine. Configure and launch. So launch, I'm going to use my existing key here, demo key. Launch instance. Let's move to your EC2 console and launch another instance. So the VPC would be demo VPC and subnet would be private. That is fine. Click on next, add. So this is your instance store volume. Click on next, add security groups. So let's create a new security group. Private demo SG. Launch and keep here would be same. Let's move to your EC2 console and give a name to this instance, which is private demo. That means that is attached to private subnet demo VPC. Demo VPC. So there is one more which is public demo. So this would be a meaningful name, so we can easily identify our instances. So that is running. So let's check. Let's connect this instance to internet. Let's get the console. So demo key, click on open. Yes. So we are able to get the console of that EC2 instance. Okay. And this is the private address. You can see. now let's check. So as you can see, we are not getting the DNS name. Why? It's because we didn't select that option into our VPC. So by default, you will not get DNS name to your EC2 instances. So if you need, just go to your VPC and select your VPC and go to action, and there's option DNS name resolution, which is enable. Okay, and use DNS host names enable. So that you need to enable from here. Okay, so when you will enable this that DNS setting from here, then your resources would be able to get or the DNS name automatically. DNS name. So now you can see there is a DNS name attached to your instance. Is it clear? Now let's check the private demo. Go to actions, and there is no option to connect just because there is no internet connectivity. Sorry, click on connect. This is the private public address. So the private address. So we are not able to take the console through private address. Why? Just because if you want to take console, you need public address for that instance. Okay, but we can take uh, we can take SSS console inside from our public instance because they both are in our same VPC. Okay, so for that we need to enable first of all communication. So let's do one thing first of all. Move to your instance. Okay, let's check the IP address of that instance. That is 10.0.1.210. So let's check that we are able to ping that IP address or not. So our IP address is 10.0.0.172. We are going to ping 10.0.0.1.210. So we are not able to ping. You can see here. So first of all, we need to enable communication. Then we'll take the console of that EC2 instance here. Okay. That means let me show you one here. What we are going to do, as I told you, that web application needs a communication with RDS. So through private. Private means we will enable communication between your subnets. Okay. So for that, we'll manage that thing through security rule. So let's do one thing. First of all, let's check that they are not able to communicate. So move to your portal and scroll down and let's move to security groups. Let's open private security, inbound rules, click on edit, add rule, custom TCP, custom ICN, and address would be 10.0.0.0/24. Now let's check. Refresh your instances as well. So one second. all ICMP. So you can see we are able to communicate with that address. So you need to enable communication between your private subnets, then you would be able to take access. So now, how you will take the control of the TCP instance? Okay. So let's do one thing. Let's take a small break of 5 minutes. Then we'll do that. So I'll show you how you will get the console of that private subnet, private instance. Okay.
This conference will now be recorded.
So welcome back, guys. Now, as we are able to communicate with our private VM, now what we need, we want to manage that VM. Okay. So for managing that VM, we need console. So as we don't have any public access to that VM, because that VM is placed into private subnet. So we can access that VM through public subnets because the private communication is enabled between both subnets. So for that, what we need, let's check. Let's move to your portal and select your private VM. Connect. So what you need that public key. Okay. So what I did, so I have a bucket where I have already uploaded that key on my bucket. Okay, demo keyboard tab. That is already uploaded into my bucket. So now I will download that key inside my that public VM, and then I will assign the permission. You can see I need to change the permission of that key, and then I will run that command, and I would be able to access the console of that VM through SSH. Okay, internally. So let's do one thing. So for accessing S3, if you check here, sudo su, and there's a command AWS S3 ls. So it will list you all the buckets which are available into your S3. So right now, you don't have any permission. Okay, so you would not be able to access any S3 bucket or any S3 command. You are not able to run any S3 command. So for that, you have to assign a role to your VM. So that role I have already created. Okay, and we'll see that how to create role into IAM section. So right now I have a role and I'm going to assign that role to my VM. Just go to action tab and instance setting. There is option attach and replace IAM role. Move here and click on drop down. So there is a role EC2 full access to S3. So we are going to give full access to that instance. Okay, then just refresh. Let's move to your console and type here AWS S3 LS. So this is the bucket which is available in my S3. So you can also verify that is the bucket. Now we want to download that demo.pem file. So for downloading that file, there's a command AWS S3 CP, then S3 URN of uh, your file. So that is SAM 749 slash the file name demo key dot pem. So before downloading this, what I'm going to do, I'm going to create a directory npdir slash data cd slash data, and I will run that command here. So I will download that file in slash data. The file is downloaded ls. This is the file. Now run that command, permission command. Select the VM, click on connect, and copy this command. Sorry, first of all, you need to copy this command, switch mode. So this will change the permission. So I'm not going to discuss about the permissions of Linux. So So I hope you all have knowledge of that. So this command is used for changing the permission. So read, write, and execute. So the permission is changed of that command. Then we need to run the next command, which is for getting the console of that VM. So run that command, and you are connected with that private VM. Okay, so you can see the IP. So right now it's 1.210. So our VM's IP address is 172, 0.172. Let's check that this VM is able to communicate with your internet. So ping google.com. So there's no communication. Okay, there's no. So now, right now, you can configure settings. You can install your packages here, but still you need internet if you want to install any package from through internet. Okay, so for that, next topic is how you will enable internet connection. Now we have to enable internet connection to our private VMs. So what we can do, we can create a internet gateway, and we can attach that gateway to our private subnet, and then internet would be available to that instance. Okay, but we don't want to expose our private subnet directly to the internet. So this is not the right way assigning internet to that instance. So what we can do, we have two options for that. We can create a NAT gateway in public segment, and which we will assign to a private subnet, and then this VM would be able to access internet securely. Okay, so internet will be available in secure manner. I hope you all knows the NAT. What is NAT? Network address translation. It maps your private address into public address and vice versa. I'm not going to going in detail of NAT. So you can create a NAT gateway, or you can create a NAT enable instance, a NAT instance in public subnet, and then you can add that instance into your route table of private subnet. Now, now let's understand what is the difference between NAT gateway and NAT instance. So if you will use NAT gateway, so this will be available 24/7. That means you will get better HA. Okay, this will be highly available. If you will use NAT instance, so let's suppose if there would be any patch, or if there would be any service upgradation is going on onto your instance, so might be your instance will be down for 1 hour, 2 hour, 3 hour, or if your region is down. So that means your VMs will not get internet connection. This is the drawback to using NAT instance. So both will provide you internet. Both will provide internet to your private subnet, and through NAT gateway, your internet access will be available 24/7. This is the only difference. Okay, so now let's do one thing. Let's move to your console, open VPC. Let's check how we can configure NAT gateway. So right now we are on VPC page. First of all, just do one thing, just to go NAT gateway and click on create NAT gateway. So you need to just remember one thing. You will place that NAT gateway into public subnet always. Okay, so select your public demo subnet. Then it needs a elastic IP address. And if you are doing lab practice, so you have to remember your NAT gateway. Why? Just because it is attached with a elastic IP address, and you have to pay for elastic IP address. Elastic IP address is not free. Elastic means static IP address, static public IP address. This will be assigned with your NAT gateway. Click on create NAT gateway. Close. So this will be created. Let's give a name to this demo NAT CW. Save. wait for a few minutes. So private address is assigned to this net gateway. We have to wait for the elastic IP address. So you can see here, right now there is no communication to internet. After attaching NAT gateway, this VM would be able to access internet. So elastic IP address is assigned to our NAT gateway and it is available. Now we are going to our route table and we'll add our route into private subnet. So there is a private demo route table. Go to routes, edit routes, add route. So we need internet connection. So that means we must allow all communication from internet and target would be NAT gateway and that is the available NAT gateway. So click on it and click on. When you will click on save routes, so you will get here you can see that your VM would be able to communicate with Google. So you can save routes and let's check here. So your VM is able to communicate with your internet. So now you have a internet access on your private subnet in secure manner. So hope all things are clear to you. Okay. Now next topic, which is VPC peering. VPC peering means you have two VPCs, okay, and you have subnets inside your VPCs. Now, what you need, as both VPCs are isolated, so that means there would be no default communication between those VPCs. Okay, so you need communication. So for that, you will enable peering. Okay, VPC peering. So how you will enable that VPC peering and how your VMs will communicate with each other, we'll see all these things practically. And you need to remember one more thing, which is that the VPC peering is not transitive. Transitive means, let's check, take a scenario. Let's suppose that is your VPC and that is your other second VPC and that is your third VPC. So if your VPC 1 and 2 appeared and then the 1 is paired with 3 and then it doesn't mean that if you have appearing between 1 to 3 and 1 to 2, so you have appearing with 1 to 3 to 2 default pairing. That is known as transitive. So VPC pairing is non-transitive. Okay. So if you want communication from 3 to 2, so you have to separately pair your VPCs. 2 to 3 VPCs. Okay. So let's do practical. Let's move to total. Open VPC here. Let's create another VPC. So do one thing. Now I'm going to show you VPC through the template. So one VPC with a single public subnet. Select. So range I'm going to use here 20 and VPC name would be demo 2, and CIDR block would be from my subnet 20.0.24. Availability zone would be 1.c. This will be public subnet. Okay, rest things will be default. Click on create. So this will create a VPC. This will create a public subnet for your VPC. So demo 2 available. There will be a subnet, public subnet, public subnet. Okay. That is okay. Now do one thing. Move to your EC2 console. Launch instance. So I'm going to select demo 2. Leave things default. Security group. So existing. There is no existing. So demo 2 SG. Launch instance. So we have created an instance. Second VPC. Let's take the console effect instance. No public address is assigned to that instance. Okay. Let's check your VPC, public subnet, action, and modify auto sign settings. Okay, that was not enabled from here. No issues. And your VPCs, go to your VPC and select host name. That is enabled. Okay. So the application is enabled and host name is enabled. So both are enabled. Now let's move to your EC2 instance, refresh it, signal correction, networking, allow the assignments, home. Ah, so do one thing, just create elastic IP address and attach that elastic IP address to your instance. So we have already an elastic IP address. So what I'm going to do, I'm going to delete. First of all, NAT practical is done, I hope. So you all have the knowledge of NAT. So let's do one thing, just delete NAT gateway. So your elastic IP address will be released. So go to action, click on delete NAT gateway. So when you will delete, so it will release your elastic IP address and then you can use that elastic IP address to another resource. Let's move to elastic IP address and action associate address to instance which is demo2. Select private address, so private address will be this 196. So associated with our EC2 instance, let's move to EC2 console and instances tab, refresh it, and let's do one thing, select demo, click on connect, Now copy this. As you can see, now we are getting public DNS name as well. Let's do one thing. Get a new session, SSH authentication, browse, demo key, and over. So let's check once again. Let's check the firewall. So port number 22 is enabled. Okay, let's not worry about that. This is the network issue, network error issue. So no need to worry about that. We can do that thing on our public. So let's check. We have a private IP address. So let's try to ping that address from here. So you not any reply. So what we are going to do, we are going to enable VPC peering. Then they would be able to communicate. So let's move to your VPC and scroll down, and there is a peering connection. Let's go to peering, create peering connection. So demo 1 to demo 2. So requester is demo 2 and acceptor is demo VPC. Create peering connection. Click on OK. Now just move to, you can see the peering status is pending access. Right click here, accept request. Yes, accept. So connection is established. Now it is active. Now just move to your route table. Double tap routes, edit routes, add routes from 20.0.0.0 slash 16, and target would be peering connection, which is this. You can save routes. Now let's check, and we need to enable that on demo 2 route table as well. This is the demo 2. So let's click on edit route table, then click on add routes. So we have to add from both sides. So 10.0.0.0 slash 16 and getting connection. One more thing we need to enable, which is ICM. Select your security group, which is attached to your EC2 instance, and edit inbound rules. So add routes, all ICMPv4 connections, all ICMPv4 connections to 10.0.0.0/60. So this case will take some time, few seconds, and you would be able to communicate. So there is a network connection error. You can go and take the console once again. Public demo. Sorry. Sudo space s. Then let's check this one now. We will be able to get console of that also. Private demo and click on connect. Okay, this command. Permission denied to access system slash. So ping, what was the IP address? Demo to we have selected the set address. So VPC peering connection is done. Let's move to route table. So let's go to public demo as well. Let's edit public demo as well. 20.0.0.0/16. Target is peering connection. Close. So we need to check our minimum range. That is okay. 10.0.0.60. So there is some network issue in what in that VPC. I'm going to do one thing. Elastic IP address. I'm going to release that elastic IP address first, and DS would see that address and just move to your instances and select your demo to instance settings and networking. Manage IP addresses. So I'm going to send the second IP address. So, yeah, that's done. Now move to elastic IP address option, associate and demo to associate with the instance data flows. Fresh connect. Copy the IP address. Open a new session. EC2 dash IP address authentication. Yes. So we are able to take console of that VM. Now let's communicate with that address. Ping dot 10 dot 0 dot 0 dot 172. So we are not able to ping that machine. Okay. Now let's check communication with 0 1 dot 210. Let's move to subnets. Let me do one thing, create subnet. Public demo. Hmm. So I have to enable ICMP connection to private demo security group as well. So edit inbound rule or ICMP v4 from 20.0.0.0/16. So you can see this is pinging. So you need to enable, you need to take care about the firewall which is configured. Now you can see you are getting reply from 10.0.1.210, which is a private VM of VPC1 demo VPC, and this is the IP address of demo to VPC. Okay, and for here, same we need to enable firewall rule. Okay, so hope this would be clear to all of you how you will enable VPC peering. So close, and you can create, you can connect your environment through VPN gateway as well. Okay, so when you will use site to site, there is option site to site VPN connection. Okay, so when you will use that connection, suppose that is your on-prem network, and that is your Azure AWS network, AWS, and this is your VPC inside your AWS. Okay, and they are subnets. And that is your on-prem, and there are subnets. Now, what you need, you want a hybrid connectivity from AWS to on-prem. So for that, what you need site-to-site VPN connection. Okay, you will get a site-to-site VPN connection, and then you would be able to communicate with your on-prem network. So when you click on site-to-site VPN, there is an option click to create connections. So name, let's go like virtual private network gateway. Okay, so you need a virtual private gateway which we will create from here. Okay, so first of all, you need to create a VPN gateway. VPN gateway, let's local GW. Okay, so we are going to use default ASN. So basically, now you have to attach that to a VPC. So which VPC you want to allow with your VPN gateway? Let's suppose demo VPC. Then just go to site connections and create VPN connection, name, so local VPN, and gateway is there, select your gateway. Now customer gateway is existing or new, so let's select new. Okay, so now here you have to give the public IP address of your on-prem network, and if there would be any BGP, then you give the BGP ASN as well here. Okay, and certificate of that ASN. Then routing options are dynamic or static if you are using BGP. Okay, scroll down, you'll create here the CIDR address and your pre-shared key. Okay, so again, CIDR if there would be multiple CIDR subnets inside your on-prem, so you will specify those subnets and pre-shared key, and then you will click on create VPN. So you'll get the profile for your firewall. So you can configure your profile through here. Okay. So if you are a customer gateway, if you have existing customer gateway which you have already configured, then you can select the gateway from here as well. Okay. So right now I don't have any public IP address, so I'm not going to create that VPN gateway here. Okay. So you need to enter here. Let's check that option. You need to enter here public IP address of your on-premises. Okay. BGP, if there would be any BGP, so BGP and then certificate of that AR, and Dynamic routing option would be dynamic, or you can use static as well. Then you have to create a static routes as well. Okay, so dynamic and static, it is totally up to you. Then you will specify here your subnets which are configured inside your on-prem, then your preset key, then again the different subnet, the second subnet, and then preset key for that subnet. So it will create individual tunnels for your all subnets. Okay, and they will be connected with your AWS network. So when you will click on create connections. Okay, so as we didn't give these addresses here. So when you click on create VPN connection, it will create a VPN connection, and you can download the configuration of your local firewall as well from here. So let's suppose you will get a few vendors specific configuration here, like Cisco and F5. So these firewalls, ASA firewalls, okay. So these firewalls configurations are there, okay, which you can download, and you can do the configuration on your on-premise firewall, on your local firewall, as per the configuration is provided by AWS, and then your network would be connected with AWS. So this is all about the VPC section or networking section. Hope this would be clear to all of you. So if there would be any questions, you can ask to me, and I'm going to show you how you will delete all these things. So first of all, I'm going to virtual network, click on detach from VPC. So then select and delete virtual private. Then scroll up and select peering connection, action, delete peering connection. Yes, delete. So it's deleted. It will remove after few minutes from your portal. And net gateways. So net gateways are deleted. Just go to elastic IP address and select. First of all, you need to deassociate your elastic IP address which is associated to your instance. Then release. Be careful when you are getting any elastic IP address for your lab practice. Just deassociate after your lab practice. Otherwise, otherwise you will get an invoice from AWS. So elastic IP addresses are chargeable. Then move to internet gateways. Okay. Let's move to your VPC. Select your VPC, action, and delete. So what it is saying, there is a instance. So we need to shut down our instance. So what I'm going to do, our practical is done. So I'm going to terminate all these instances. I don't need this instance anymore. Now let's move to your VPC, action, and you want delete VPC. Just delete. So everything which will be associated with your VPC, that will be deleted. Now let's delete your second VPC, which is demo VPC. So that is done. Right now we have only one default VPC. So this is done. So if you have any query, you can ask. So next session would be on IAM goals. So bye bye guys. Take care.